Hello, my pre-algebra friends. We are in a new chapter. Yay! And this is a fun chapter. It's a really useful chapter. It's one of those math concepts that you're going to use a lot in the real world, besides in your advanced math classes. So this particular unit, we're talking about ratios and rates. I seem to have lost my pen. There it is. So you can look at the definition in your book, but a ratio actually compares two quantities by division. I think I added an extra S in there. So if you notice the word ratio, and you remember last chapter we talked about rational numbers, which were just fractions, numbers that could be written as the quotient of two integers. Well, ratio is the root word in here. So we're going to continue to talk about fractions, but this is a little bit different concept. We are going to have a fraction bar, but we're going to be looking at the quantities that we're talking about as well as the numbers. So the reason why this is a big O, a capital O, that's not a mistake. It is to differentiate between a ratio and a rate. A ratio compares two quantities, and this is important, add that are the same. The quantities are the same. So when we write them, you'll see that the quantities actually cancel out. The English word that defines the quantity actually cancels with himself in the denominator, and we're just left with numbers. So the example that I give you here, all right, this is going weird on me, as you can see. What's up with that? Let's see if it's settled down. The example that I give you is something maybe you've heard on TV. It used to be an old advertisement. 5 dentists out of 6 dentists prefer Crest. So if we were going to write this as a ratio, we're comparing 5 dentists to 6 dentists, and anything divided by himself is 1. It cancels out. So because these units are the same, this is considered a ratio, and we write it simplified as 5 over 6. There's 3 different ways you can write ratios. You can write them with the fraction bar. You can write them with a colon. Or you can write them with the English word to, 5 to 6. We're comparing 5 to 6 dentists. This says 5 out of, that's what the colon means, 6. So all 3 of these written expressions mean the same thing. We should always write ratios just like any other fraction. We need to write it in simplest form, reducing, always looking for common factors until your numerator and denominator are relatively prime. So 8 students out of 12 students did their homework would be written like this, because the students, the word students over students that went with the 8 and the 12, they cancel, and we get 8 over 12, but that reduces, of course, because 4 times 2 and 4 times 3, that reduces to the ratio 2 to 3. All right, let's look at the next page. Here's one that's interesting, and we're actually going to go back and do some more conversions like we did earlier in the year. If you have the opportunity to have the same unit, but you don't have the same unit, you need to convert. And then that would be considered simplified. So 2 feet to 10 inches, well, feet and inches are not the same unit, but you could make them the same unit. Instead of writing 2 feet, there's 12 inches in a foot, you could say, okay, well, that's the same as 24 inches, and now my inches would cancel, and my 24 and my 10 have a common factor as well, which is 2. So my final reduced ratio is 12 to 5, 12 over 5. No units because they've canceled. Now we're going to introduce the idea of rates. And this capital E stands for per, big E, per per, and I'll explain that in a minute. And this is a special kind of ratio. In other words, we're comparing two units, but now the two units are different units. So we compare two quantities that have different units. Different units by division. So because the quantities are different, they do not cancel out, and they stay with us through the entire problem. They're integral, meaning they're important to the problem, and they never cancel. The most famous and the most used kind of unit rate are rates where you have a denominator of 1. So let's talk about unit rates a little bit. So here's an example. I can give you a rate, 24 people to 6 cars. Well, these don't cancel because people aren't cars, and you can't make people into cars. So they stay with us, and that is a good fine rate. This is a rate because the units are different. But it's not a unit rate because this denominator is 6, not 1. And to be a unit rate, your denominator has to be 1. So if I wanted to make 24 people in 6 cars, let me get that better, and I wanted to make my denominator 1, all I really need to do is divide the 6. To get 1, I divide both the numerator and the denominator by 6. And then I have 1 in the denominator and I have 4 in the numerator. So 4 people per, there's your word per, indicates a unit rate. 4 people per car, and you write that 4 people and your denominator is 1 car. So we're going to use unit rates, and we're going to do some stuff in class where we use it to tell whether or not prices, which is the best price for stuff that's sized differently. Let's see what's on the next page. I think we're talking about equivalent. Nope, we're not. All right, so in other words, here's another example for unit rate. $3.45 will buy you 6 ounces. So the money goes on top. Please write that, money in numerator. For 6 ounces. So this is a rate, but it's not a unit rate. Not unit rate. Because its denominator is 6. If I want to know what the unit rate is, I have to divide the numerator by the denominator. And I get about 58 cents per ounce. 58 cents per ounce. And that means per the ghostly 1 ounce. But we don't say 1. It's like the ghostly 1. We leave it out. So I want you to get a calculator. So pause the video now if you don't have a calculator. And I want you to go figure out the unit rates for me. So I'm going to set this one up. 60 songs in 5 hours. So our question is, how many songs in 1 hour for the unit rate? So we want 60 divided by 5, and of course that's a math fact that you know. So it's 12 songs per hour, or 12 songs in 1 hour. So you do 2, 3, and 4, and then come back and listen to the rest of the video. We're going to talk about equivalent, meaning equal. That's another fancy word for equal. We're going to talk about 12 to 9 and 24 to 18. Well, these look like normal fractions, and we really should say ratios here, because these have no units, which means the units were the same and they canceled out. So we're trying to figure out whether these are equivalent. Do they occupy the same space on the number line? And there's a couple different ways to do this. We can, number one, we can reduce each fraction to its simplified form and see if we have the same thing, or we can find a common denominator. So let's just run both of these for number 5 anyway. So 12 over 9, the first way would be to reduce it. So that's 3 times 4 and 3 times 3. 4 and 3 are relatively prime, so I'm done with 12 over 9. 24 and 18 is 6 times 4 and 6 times 3. And yes, 4 over 3 equals 4 over 3, the simplified form. That's the first way. The second way is a common denominator. So obviously 18 is the common denominator. I don't have to do anything with the 24 over 18, but 9, I need to make him, I need to double him, so I need to double the 12, which is 24. And you can see now we've created 2 equal fractions, and we've proved that yes, these are equivalent. Let's look at number 6, 14 to 4 and 21 to 8. Again, you can do either one of these methods, or you can do both if you want. I'm going to double 4 to make 8s because this seems like it's the easiest thing to do to me. I don't have to do anything to the 21. So 4 doubled, which means I have to double 14, which is 28. These are not equal. They are not equivalent. Last page, I want to talk quickly about this, and then we're going to do more of these in class. This is these are the real typical unit rate applications. So you go to the store and you got your choice. You want peanut butter. You're going to buy peanut butter. And you see all kinds of different peanut butter. You've got a 12-ounce jar, and it costs this much, and then a smaller jar, an 8-ounce jar, costing this much. So if you have your calculator handy, the first thing you're going to do is you're going to compare. You're going to compare the 12-ounce jar, money on top, money in numerator. So we've got $2.95 for 12, and you need the unit. Your unit is money, and your unit is ounces. Our question becomes, how much for 1 ounce? Let's get a unit rate so that we can compare to the 8-ounce jar, which is, and I got the prices wrong. Sorry, that didn't make much sense. All right, I'm going to go back and start again. The 12-ounce jar is $3.49. The 8-ounce jar is $2.95. So we can't really compare because they don't have a common denominator, 12 and 8, but if we get both their denominators down to 1, then we can certainly compare them. So you hop on your calculator, you do 3.49 divided by 12, and you get 0.29, 29 cents per ounce. Will you write that, please? 29 cents per ounce. That's the unit rate for our first option. The second option, 2.95 divided by 8, and you get 0.37 rounded up, 37 cents per ounce. So going just on price, just on the unit rate, we would say that this guy is a better deal. This 12-ounce jar is the better value. And we'll talk a little bit more about that in class. I think there's one more with some Cheerios. Cereal, the same thing. We're looking to compare a $3 box of cereal that holds 20 ounces and a counterpart, which is $2, and he holds 12 ounces. So right off the top of my head, I don't really know which is a better rate because they have different denominators. But if we get a unit rate for each one of them, then we can see which one is a little bit cheaper. So we're going to take 3, and we're going to divide it by 20, and we're going to get 15. His unit rate is 15 cents per ounce. Please write that, unit rate. This guy is $2, and we're going to divide him by 12, and we get closer to 17 cents rounded. So again, if you're only going by pricing, this guy, which was the 20-ounce box, was a better value. Okay, I'm going to stop now, and then we'll do more of this in class. See you then.